Greetings, it's Howard Harris and Graham Scher here from SPEnergy with a tutorial on your SpCalculator. If you press on the icon, which should be on your desktop when you've downloaded the software, you'll find a screen pops up which looks like that on screen currently. It is divided into two halves. The left hand side is for opening your workbooks every time you have a new project, and when we open our first project today. And then on the right hand side we've got a print portion, and that we will use towards the end of the session when we're going to print out the work which we are discussing today. So I'm going to press on Open Workbook, and that should find its way to my projects directory, and I have a user book example as you will hopefully find in your system when you first open it up. I'm going to go to full screen, and you'll see a spreadsheet, first page of which is the standard warning on the inadvisability of trying to hack or steal the IP. On the next screen, pressing the next button, we go to the first of 12 tabs, and that is entitled, as you'll see down the bottom of the screen, the project details. Graham, please chip in if I'm neglecting any important aspects. On the right hand side of the entry part of the sheet, you'll see some general instructions with regards to the ownership, the use of the spreadsheet tool, which is twofold, and in other words, it's to be used as a prescriptive report for council submissions, or secondly, perhaps as a entry for a SPEnergy energy modeling takeoff. So the white blocks are required for the prescriptive, and the grey blocks, which you'll see coming later as we go through the sheets, are only to be used if you are following a rational design. So there are some notes to each of these tabs which appear in the orange blocks on the right hand side, and I'm sure you'll find much of it is self-explanatory, but I'm sure it'll be helpful to go through it. So in the project name, one needs to enter up some sort of labeling for the project, and we're following an example in the SPEnergy training material, and the example happens to be on page 121 if you're looking for the reference. It's a very simple little structure, and we'll be talking through that during our training material. So if you visited our training material, this will look familiar. Right, the first important field after the general information is the selection of the occupancy. So a drop down is available, and in this instance obviously the residential building we need to label as an F4 dwelling house. Important thereafter is that we define how many such buildings and how many floors we have in this building. It's only one in this case, but we do have 3 bedrooms which we need to enter. The software automatically extends that 3 bedrooms by the statutory 2 persons per bedroom in table 2 of paragraph A21 of part A of the National Building Regulations. So, or rather SANS 10 400 part A. So we've got a calculated 6 persons in occupation of this building. We have an opportunity to override that if we perhaps were doing a rational design or felt confident that the rooms were small enough to be labeled as single rooms, and a smaller number of people would apply. The entry of your site location is a free field, but the field below is a selection of the climate zone. So you would need to consult your climate zone map in the handbook or in the standard, and you would pick up that Johannesburg is in climate zone 1. So using the next tab at the bottom, we will find our way onto the next slab. You may on occasions need to readjust the zoom on each of these slides, and it's necessary to go in at 75% to get everything on the screen. So the next most important fields are to put in your gross floor area and your net floor area. Particularly your net floor area needs to be measured accurately. Your gross floor area is only to be used for the lighting power density calculation. So we've got in this instance a net floor area of just over 101 square meters, I believe, and we enter that number and we go down the screen and see that there's only one other bit of information, and that is that the major axis of orientation needs to be identified, and the direction that that axis faces needs to be entered into the drop down. And the drop down will should correspond with the SANS 204 orientation sector options as are shown on screen where my cursor is circulating. Now if you drop down to the next button, we'll proceed then to a tab which is entitled the slabs, and getting it back onto 75%, we'll see that this section requires that for any of 5 possible floors, we need to indicate from the drop downs as to whether they be slab on ground or perhaps suspended slabs, in which case we would put in no. And the further to that is whether heating of that slab is to be provided. If there is heating to be provided, let's say we had a yes there, then we would need to go further down and input the relevant level of insulation. So we could try it at 0.5 and it would generate a non-compliance, and that's because the minimum level of insulation for insulation underneath a slab with in-slab heating would be an R value of 1. So any number of floors might have that insulation requirement, and if we fill in the blocks appropriately, the comforting compliance message is shown. So with the next button we can proceed to the walls tab. The walls tab is changing significantly in the 2020 version, and that's because the definition of the compliant wall is changing quite a lot. Presently we only have to make a selection between masonry and non-masonry, and for climate zone 1 we'd be looking for 2.2, and for a masonry wall 0.35. We do set out some options that might meet this requirement, and there are hollow concrete blocks and some plastered walls. If you could just select the closest approximation to that particular wall, it will show the compliance message. I think if there's any deviation in your wall structure from any of these standards pre-selected descriptions, one would need to put in the closest and then have it obviously detailed in your plans as to what the exact construction might be. That takes us then to the next tab for the roofs, and if we just make sure it's on 75% again, we have a descriptor at the top of each of 3 sections, and we might be building with a as in this particular example on page 121 of the handbook, a tiled roof with a pitch in the range 17 to 45 with a plasterboard ceiling. We in the grey blocks need to supply the roof area, not a mandatory field though, but what one should do is check and see that the configuration which you're detailing in plan does achieve the requisite R value required. And that is set out in the top of each of these three sections. So 3.7 R value is required, and we then need to check and see whether the, let's say, a 20 millimeter tile in conjunction with 120 millimeters of cellulose fiber, or perhaps we could use the drop down and we find a similar performance fiberglass insulation. It's contributing an R value of 3 to the total R value. We have also a reflective foil plus air spacers in situ in this design. So we would need to make this selection of a horizontal to 45 degree sealed airspace with reflective foil liners and for heat flow upwards. So if we are installing a plasterboard of, let's say, 6.3 millimeters thick, and we adjust that, we are getting to an R value of 3.75. So that's giving us that comforting compliance message. And similarly, we might have other roof constructions in this building. We don't have in this case, but we might, for example, have a somewhere in the project a concrete deck with a ceiling below, and that concrete deck would also require to be insulated. And if we were to use an upside down roof, we would need to have a ballast, and that might need to be 60 millimeters of stone with, let's say, 100 millimeters of polystyrene, extruded polystyrene. We wouldn't quite get there unless our concrete slab was fairly substantial. 255 millimeter slab. If not, we'd have to boost the insulation level slightly. Of course, we wouldn't have any plasterboard in all likelihood, so we would need to zero out the plasterboard, and that means that we're probably back at slightly over 100 millimeters of insulation to get to where we need to be. So there is... Yeah, Graham.
That the manufacturer's isoboard will make up the thickness that is required to the exact thickness that you need.
On the roof light, which is the next tab, if we go through to the bottom, we'll see the link provided. Again, we need to zoom to 75%. And if we, let's say, we don't actually have a roof light on this particular building, but if the whole building, let's say 101 being the area served, the whole building was served by a central roof light, which might be 2 meters by 1 meter in extent, and let's say we have one of them. At the outside dimension, it might be slightly smaller, so let's say 1.8 by 9, and if it had a depth, in other words, if it was multi-layer with a layer in the outside of the at the roof and also an inside diffuser with a 250 or let's say 200 millimeter gap between the two surfaces, we would find that the sheet calculates that the SHGC of 0.75 would be required and a U value of 5. This could probably be achieved by a single clear glass solution with diffuser, and one would need to insert that combination in place, and let's put in some fictitious numbers which we can get, which we assume which we've obtained from our friendly supplier. And having done that, we get to the comforting compliance button again, and we're able to move on to the next tab. The tab on air filtration and air leakage is simply a check to see that certified windows have been sourced, and these would be certified by ARMSA as having been tested to provide the requisite leakage, and if we're installing certified windows, we would be in compliance. There's no change here with the new standard except that doors will come into this consideration, that is external doors. The next tab takes us to lighting, and the figures carried forward from the takeoff of the gross floor area and the targets per square meter for energy demand and energy consumptions automatically appear. It presents us with the maximum energy demand and consumption allowances for this particular building. So it really just requires for us to enter in the different types of lighting which might be used in this particular house. Now, if we were to go with, let's say, LEDs rather than CFLs, they would have an efficacy, which you can see on the right here, of approximately 80 watts per square meter. 80 lumens per watt. So that lighting efficacy needs to be entered if there is a exceptional lamp being used. If we had, let's say, 30 of these lamps distributed around our 100 odd square meters, and each of them is, let's say, conservatively 8 watts per square meter, we're getting to, in conjunction with two other linear LEDs, perhaps in the kitchen, the compliance is demonstrated for both the lighting power density, or the connected load per square meter, the energy usage based on 1,000 burn hours, and also the lumens, demonstrating compliance with the SANS 10114 standard. And that would be adequate to prove to any building control officer that their lighting was in compliance. We then move to the 9th tab, which is the tab on the water heating, and in this instance the figures which are carried forward are quite useful, in that the number of persons that we've entered into tab number 1 carries forward. We simply have to make a selection of the residential character and a selection of somewhere between a sub-economic, low rental, medium and high rental option for the hot water usage. Now, in the standard, the 10400XA document reads that guidance is given. For that reason, we've used our experience and knowledge of the hot water subject to ensure that the tool gives you an accurate reflection of what you can expect in terms of efficiency from this equipment. So we are recommending currently low rental number selection, and that throws out a consumption of 80 liters per person per day of hot water. Now bear in mind that not all water is used at 60 degrees, and it is mixed, much of it, to a lower temperature, but effectively one needs to provide for enough hot water at approximately 60 degrees exiting that geyser during the course of a day. So that is our consumption, or our usage, and it totals 480 liters in a day. Now, in order for the solar water heater to be meeting the 50% minimum non-resistance heating requirement of regulation XA2, and if you can see my cursor circulating that important bit of legislation, or rather regulation, the sizing of our geyser is paramount. Obviously the sun only shines once for a period of approximately 10 to 14 hours during a day, and so there is a 24-hour heating cycle. We have to accumulate at least half of this 480 liters in our daytime, in our sunshine period. So we need to be storing at least that by the time the evening arrives. So a geyser of less than 240 liters would not be satisfying this minimum non-resistance heating requirement, because it would then mean that more than 240 would be generating by the way of electrical reheat, and that would be probably occurring mainly at night or in the early morning. So we wish to avoid that as far as is possible, and we therefore have to have the requisite volume installed. An input of the matching heating power is also required. The matching figure, Graham, in Cape Town, you wouldn't go over 24 megajoules, I believe, your experience.
As a rule of thumb, you generally have the output power as a figure of 10% of the liters of storage. And that's a good rule of thumb. We find generally if you increase it, there is a chance of burning out the geyser in summer.
Yes, if your collector plate or your vacuum tube system is suboptimally orientated, let's say if it faces either east or but preferably towards the west, the possibility of boosting that does exist, but as Graham says, one needs to be very careful about that. Particularly in Cape Town, where you have extremes of very high solar insolation in summer versus low insolation levels in winter. We only have one such unit installed in this particular house. We need to enter up the 1 there, and then we need to just discuss the possibilities that this house has a heat pump installed. And we are using the same volumetric determination, and then just assuring that we have more than a value of 2 installed with wastage. It would need to be grossed up to ensure to a COP of 2.5 to ensure that we are getting more than the 50% minimum non-resistance heating being achieved. So the comforting compliance message appears if we have our volumes correct, if we have sufficient heating power, or on the other hand, if we have a sufficiently low COP supplied by our heat pump supplier. And please do not hold back on consulting with either Graham or myself on the subject of hot water, because many instances of heat pumps supplied, there's insufficient heating capacity and people are disappointed. Many are the instances where the solar fraction is dreadfully low, 28%, and you can see that if we were to increase this beyond, incidentally, this 240 would be the statutory minimum size for a 6-person's bedroom, because it would be 6 persons times, as per table 5 of SANS 10400XA, 40 liters per capita. That would give you a 240 minimum. But if you were to move this to, let's say, a 300 liter tank with 30 megajoules of heating power, you can see that your solar fraction pushes up by a factor of 25%. And this would be the new level which the SANS 2020 edition 2 would be striving to achieve. Graham, any more comments on the hot water from you there?
I think it's important to remember that one shouldn't really go for the absolute minimum in terms of the current legislation. And you do want to have as much water storage to cater for morning ablutions, considering there's no sunlight in the nighttime. And so you do want to have about a 300 liter system for a 3-bedroom house, at least. Yeah.
Good. All right, the next tab is, I should mention the minimum pipe insulation needs to be installed. and we can then move to the next tab, which is the fenestration tab. Now you'll see in the fenestration tab that in the top section the results are shown, where you can see where my cursor is circulating. That is your results section. We have a section below that which I'm going to call our performance section, and this is basically where we set the budgets, or rather where the budgets are set for us by this 204 methodology, and then we have our input section below that. In this input section you start by inserting, making use of the drop downs, your ground floor, your identifier label, in other words the orientation of the drop down, the number of such windows, the size of each of these windows. The extension of area is done automatically, as is the calculation of U value, and we'll show you how to generate the solar heat gain coefficient as well. We do need two further bits of information for you to provide the model. It is the p-value, and this, if you've been on the training, you'll recollect, is your projection distance. It's the distance from the line of the glass in the wall to the extreme edge of the shading device. You also have your G value, also explained in the training, which is the distance between underside of lintel and underside of shading device. So all of those need to be calculated, input, and then the system calculates for you the H, which is the sum of your height of window plus the G value. It calculates also your P over H ratio, a critical ratio, in looking up the appropriate solar, Graham, you'll need to help me here, it's the solar exposure factor. Sorry about that. Solar exposure factor is automatically looked up. There is a automatic calculation of the contribution of that window to the conductance component, and a contribution of that window towards the solar gain component. The selection of the particular framing and glass type is also helped somewhat by the sheet. So if we go back up to the top of the table rather, we can see how that input impacts in the results. We have, as previously calculated on tab 2, the area, net floor area of the building. We see that there's 18,1 square meters of fenestration at 17.9%, and it automatically throws up a U value requirement for that configuration of glass at 6,7. What remains for us to do is to ensure that the solar heat gain component parameter is specified. And what we do is we go down to the performance section here, and the way this performance section works is that the area of the building, this 101 square meters, is extended by two constants. Firstly, a constant for conductance, which generates a total budget for your ground floor conductance and any other floors which might come into play. In this case only one, but it also generates a target for your solar heat gain component. Now what we do in this bottom section here is we generate a figure for the solar heat gain coefficient that is to be inserted in this field here. That's the performance of glass which we need as per its solar heat gain, and we put our cursors on this field here, which we need to bring.
We are compliant. Maybe we should increase the fenestration so we're not compliant, and then we can do the gold C.
All right, let's put 3 windows in the model, a theoretical 3 windows, and here you can see we are now we're not yet out of compliance, so we need to probably push that to quite a lot more, Graham. So we'll put 6 windows in there, and you
And
can
then you
see we can see now that the 15,55 exceeds the allowance of 15,15, but not by a great deal. But in order to find out what value of solar heat gain coefficient satisfies this requirement, what we do is we put our cursor in that field there, we go to the data tab at the top, we then move along to the what if analysis, and then we look in the drop down for the goal seek. We're setting the field F20 to the value of 15,15. 15,15. And we changing cell number,
So
and it's
go up and show this one now.
so it's actually cell F9. We need to enter it, and we go OK and OK again, and you'll see that cell F9 has now changed, and a figure of 0.79 is demonstrated. So in point of fact, this house is very conservatively glazed, and if we go back to our one figure for that top line ground floor D01 door, we find that the and if we put in, let's say via the goal seek again, we go data, what if analysis, goal seek, and we then look for that figure of 15,15 to be achieved, 15.15, and we look again in field F9 for the answer, enter, OK, OK again, and we'll see a very generous solar heat gain allowance is required if we only have one of these large doors on the building. So this building comes into compliance very comfortably, and you can see by changing your inputs how the requisite U value and SHGC can be generated, and then one can go to market and ask for a mix of windows which will on average meet the minimum or not less than the minimum U value requirement of 6.7 or the 0.81 it would be, which would be a worst case for a single clear glass solution. Graham, anything else that I've omitted in this fenestration exercise that comes to mind?
Just to remember that the U values is calculated automatically, so you can't have any control of that. But if you look at that figure that's in there currently, 6.7, a worst case figure is 7.9. So you're below the worst case, which means that you would need to get a certified window in order to have that U value applicable.
Yes, thanks, Graham. I think that's important. So you would probably be able to achieve this with a single clear glass solution, but it would need to be certified. If there was a lot of framing in the mix, I don't expect there would be, although some of these windows are fairly small. If there is a lot of framing, the aluminium window would take this value from the 5.8 center of glass value up to something considerably higher. So it would need to be certified by the supplier. Good. The next tab is quite a long way down because there is a huge area for input. 5 floors can be input, and there are 114 rows for each floor as possible window input lines. So we're going to use the pointer to find the next tab, which is your HVAC tab, here we just look to see whether the building is naturally ventilated or not, and it's basically a check to see that we have our 5% openable windows in place, particularly if there is mechanical cooling or for that matter mechanical heating. The selection is done for you of from a drop down here, and for a house of this type we'd be looking at a small unit, and the efficiency in terms of coefficient of performance would be thrown out in this requirement here, and we'd have to be exceeding the value of 2.5 in this case in order for a compliance message to be achieved. So if one was putting this out to contractors, one would simply nominate that a unitary console or split type unit of less than 7 kilowatts but with efficiency of not to exceed 2.5 COP should be provided. So if you've reached tab 12, the elevations tab of the SpCalculator, you'll notice that all of the fields are grey, and that's because there's no input required unless one is preparing the input for a rational design using perhaps SpCalculator. So we can then think about saving this project, and if we wanted to save it in my case it defaults to a projects file, but I believe it should work pretty well anywhere. If it's filed anywhere within your system, the program will find it, and we're just going to call this handbook example 3, and we're going to save it as such, and then we need to close out of that software. We need to get out of that software before we try and print it. So I'm going to now close it, and I'm going to look for the SpCalculator logo, and that brings up the blue screen with which you are familiar, and you'll remember perhaps at the right hand side gives us the screen, the printing options. We go to the button which says select workbook and print, and we want to provide both the submission report and the fenestration report, so we continue. It's asking us to look for our particular file in that project file, and you can see it's collating all of the pages to be printed, and I'm going to ask it to print to a PDF, and it's done. We then press the finish button, and we should have an example appearing on screen. Yeah, we give it a moment, and there we are, handbook example, and there we can run through it, and we can see it has 8 pages of output. The first page being your project page, the areas and orientation, the second page referring to slabs, sorry, to floors, and then to walls. We're then going on to the 3 roofing, details of the 3 roofing options, the R-value calculators, a section on air leakage, lighting. There's your lighting schedule. We then have a hot water page showing compliance, of course, and then there is a fenestration section below that. So here we can see the results of the fenestration section printing out with critically the U value and the SHGC requirement, which your builder would need to go to fenestration or the aluminium and glazing industry to ensure that the specifications are met. The final page is the HVAC page, and then we get into the printing of the various windows, and there you can see all of those windows that we captured earlier in the exercise are printed out, and that's really what the local authority will be looking for insofar as fenestration is concerned. You can then of course print a hard copy and present the report through to council.